In this video, we're going to go through on Red Swastika School Mathematics Weighted Assessment 1 in 2025. If you want to find this kind of exam papers, you can go to easy1.sg/SG exam to find out more. So let's get started on the first question. Alright, question number 2. Which of the following is equal to 2, 3 out of 5? So in this case, to get the improper fraction, we need to have the whole number multiplied by the denominator plus the numerator. So in this case, what's the whole number? 2. And then we multiply by the denominator, 5. And then we plus the numerator, in this case, equal to 13. So the answer should be 13 out of 5. So 2, 3 out of 5 is equal to 13 out of 5, which is option number 3. Alright, let's move on to the next question. Question number 3. Miss Lee had 6/7 of the kg of flour. She used 1/6 of it on Friday and 1/7 on Saturday. How much flour had she left? Okay, so the total she had flour is 6 out of 7 kg. And then she used on Friday, she used 1/6 of total. Okay, so it's not 1/6 kg. So in this case, 1 out of 6 of total is times 6 out of 7. So in this case, it will be 1 out of 7, right? Okay, because we can just cross multiply 6 and 6. This will be 1/7 kg. And then lastly, Saturday will be 1 out of 7 kg as well, right? Okay, so that means what's left is basically 6 out of 7, right? 6 out of 7 minus 1 out of 7 minus 1 out of 7, okay, and this is equal to 4 out of 7 kg. So the answer to this question is option number 2. Right, let's move on to the next question. Question number 4. The figure is made up of two shaded triangles and a square. The area of the total square is 36 centimeters square. Find the total area of the two shaded triangle. So in this case over here, we want to find the shaded triangle. So what we can do is we need to find a couple of things. First thing is that we need to find this base of these two triangles. Okay, so what I want to do is let me just highlight them. Okay, so first is I want to highlight this, and also this. Okay, so this is one triangle that we're looking for, and the other triangle that we're looking for is, let me use another one, which is this one. Okay, and then this one, and lastly this one. Okay, so these are the two shaded triangles. Okay, so now the thing is that in a sense we also need to find the two height, base and height of these two triangles, right? So in this case over here, we need to find the base, which is this, and then the height. So for this red triangle, we want to find the height as well, which is perpendicular, right? So in this case, we need to find this height, and then at the same time for this, we need to find the base as well. Okay, so let me just make all of this medium. Okay, so we also need to find the base, which is this, and then the height, which is this perpendicular, right? Remember, so for triangles we need to make it perpendicular, which in this case it's over here. That's what you see, like this. Okay, so now we need to just find, let's find the red one first, because it's a bit easier to see as well. Okay, so for the red one, we need to find this side. So we have this 36 centimeters square. So what you can do is, since this is a square, since area of square is equal to side times side, then that means we need to just find side. One side is the same number. So in this case, since 6 times 6 is 36, that means side of square is 6 centimeters. Okay, so we're going to write down 6 centimeters in this case, right, for both the blue triangle and the red triangle. Okay, so for the red triangle, what is the height? Okay, so since this is 6 centimeters and the height of this red triangle will look something like this, right? Okay, basically it is just 10 minus 6. Okay, as you can see over here. So that means for area, the height, so base of red triangle, so I'm going to put here triangle, is equal to 6 centimeters, and then height of red triangle is equal to 10 minus 6, and this gives us 4 centimeters. Oops, centimeters. Okay, what about the what do you call this, the blue one? base of blue triangle. Okay, base of blue triangle is 6 centimeters as well. What about the height? Okay, so we see here this is 8 centimeters, and this 6 centimeters over here is, oops, did I take it out? Yes, but this is also 6 centimeters in this case. So that means if we get this 6 centimeters with the 8, then we'll get the height, which is in this case is the blue color height. Okay, so with that said, right, now we just put the height of the blue triangle, which is basically 8 minus 6, which gives us 2 centimeters. So now we know the base and height of both the triangles, then we can just get the area. So area of red triangle will then be equal to half times base. Okay, so what's the base for the red triangle? 6, and then times 4. This will give us 3 times 4 will be 12 centimeters square. Then what about the blue? Okay, so the blue will then be equal to blue area of blue triangle is half times base, yes, 6, and then times height, which is 2, and this will give us 6. So the total area is equal to 6 and then plus 12. Okay, 6 plus 12, and this gives us 18 centimeter square. Okay, so the answer to this question is 18, which is option number 1. Alright, let's move on to the next question. Question number 5. A pattern is formed using stars and hearts. The first 15 shapes are shown like this. Alright, as according to the image. The star appears 75 times in the pattern. What is the smallest possible number of hearts in the pattern? Okay, so in this case over here, we need to find the repeating pattern. So this is a repeating pattern question. Okay, so in this case, let's look at the pattern. You have star, star, heart, star, hearts. Star, star, hearts, star, hearts. So I think you can see the pattern. So this is one pattern. Okay, and then this is two pattern like this, right? So it's star, heart, star, star, heart, star, heart, star, star, heart, star, heart, star, star, hearts, star, heart. Okay, so in this case, the pattern is star. So I'm gonna short form it. Let S be star. Let's H be heart. So its pattern is S, S, H, S, H. Okay, so one pattern in one group is this. Okay, so number of what is it called, these shapes in one group is equal to 1, 2, 3, 4, 5. Okay, so in this case, stars in one group is also equal to 3. So it appears 3 times in one group. That's why I see over here. Right, so this is one group, okay, and then this is one group, and this is one group. Okay, so now we know that there's 3 stars in one group. So if there's 3 stars, okay, in one group, then how many groups are there if there are 75 stars? Okay, so in this case is 75 divided by 3 times 1 is equal to 25 groups. Okay, so now we know there's 25 groups. What's the smallest number of hearts? So in one group, there is 2 hearts, 2H. So you want smallest number. So in this case, the smallest number, would it be, for example, 25 groups? And then there will be 2 times 25. This will give us 50 hearts, right? But 50 hearts is the maximum. So the smallest possible number. So in this case, this will be, so in an example, right? In this case, this will be the 50th hearts, okay, heart. Then that means, wait on, let me just put it here. It should be the 49th heart. Okay, so that means it's not 50th, it's 49 heart. That's what you see over here. Okay. So in that case, it's not 50, but we can just say it's 49. It's actually 49 hearts. Okay, so 50 hearts is the maximum if 75 stars appear. Therefore, the smallest number is actually 49 hearts. That can appear in the if 75 stars appear. Okay. because in this case, this 49th heart, so this star itself is 75. Okay, so 49th heart, this will be the 75th star. Okay, so yeah, there you go. So that's the answer to this question. So it's 49, which is option number 3. Okay, let's move on to the next question. Question 6a, find the value of 1300 times 200. So 1300 times 200, which is equal to 13 times 100 times 2 times 100. And this will just be 26 times 10,000 or 4 zeros. Okay, and this will give us 260,000 in this case over here. All right, so let's move on to the next question. Question 6b. What is the value of 40 minus bracket 7 plus 13 divided by 5 times 2? So this is order. Okay, this is order of operations. Okay, so that means the first one will be brackets, and the second one will then be multiply or divide, and then third one will be add or subtract. So in this case over here, this is always on from left to right. Okay, so this is good practice. So let's start with this. Okay, so which one do we start first? I think you probably know. We start with the brackets. So in this case, 40 minus, so 7 plus 13 will be 20. Okay, so now what do you think the next step is? Do we minus or do we do something else? Okay, so we do something else, which is the divide. So in this case over here, 40 minus 20 divided by 5, it should be 4. Okay, do we still minus first? No, we still have a multiply. So we prioritize multiply. So in this case will be 40 minus 8, and this gives us 32. Okay, so the answer in this case is 32. All right, let's move on to the next question. Question 7a, find the value of 4 out of 5 times 2 out of 3. 4 out of 5 times 2 out of 3. Oops. Okay, this will then be equal to 8. 4 times 5, 2 is 8, and then 5 times 3 will be 15. In this case over here. Okay, that's it lah. There's nothing much. So it's 8 out of 15. Okay, let's move on to the next question. Question 7b, find the value of 3 minus 2 out of 5 minus 1/4. Okay, so find lowest common multiple of denominators, which is in this case 5 and 4, which in this case is 20. So that means 3. Let me just copy this and paste this over here. Okay, so then what this will become, okay, this is an equal sign. So 3 would then be equal to 60 out of 20 minus 2 out of 5. We times 4, this will be 8 out of 20, and this will be 5 out of 20. Okay, so in this case, 60 minus, don't need 60, but you can have 2 minus 20. So 2, not 2 minus, okay lah. We can use 60 if you want to, right? 2, I guess put 2, 20 out of 20 lah. Okay, so 8 minus 5, this will be 13. Okay, so this will be 13, and then what's left is 2, 7 out of 20 in this case over here. Okay, so that's the answer, 2, 7 out of 20. Let's move on to the next question. Question 8a, write down all the common factors of 6 and 8. So common factors are basically numbers that we can, in a way, divide or multiply. So in this case for 6 is 1 times 6. Okay, and then so for 6, right, let me just put the arrow here. So it's 1 times 6, 2 times 3, that's it. Okay, 8 is 1 times 8, and then 2 times 4. So common factors is numbers we can find in both multiples of 6 and 8, which in this case is 1 and 2. So 1 comma 2 lah. Okay, all right, let's move on to the next question. Question 8b, write down the common multiples of 6 and 8 that are smaller than 5. Okay, so we have 6, 12, 18, 20, 50, not 5, 25. Okay, 30, 36, 42, 48, and then do we have 54? No, right? Cost must be smaller than 50. So for 8 will be 8, 16, 24, 32, and then we have 40, and then we have 48. So common multiples in this case will be, we have 48, right? And then what else? 24, right? Is that it? Yes, that's it. So it's 48 or 24 or and 48. 24 and 48 in this case over here. All right, let's move on to the next question. Question 9a, the sum of two numbers is 19,905. The difference between the two numbers is 1,905. Round the 19,900 to the nearest thousand. Okay, so 19905. So we want to round to nearest thousand. Okay, so in this case over here, that means we need to look at the hundreds place, and since so the 100 place over here, and then okay, first let me just put here 1. So second, since 100 place is more than 5, then we round up. So 19905 will then be equal to 20,000 in this case over here. All right, okay, so that's it. Let's move on to the next question. Okay, 9b, the sum of two numbers is 19,905. The difference between the two numbers is 1,905. What is the smaller number? So, okay, so we have two numbers, right? One number is, let's say, let A be a bigger number, then let B be smaller number. Okay, so in this case, we know A plus B is equal to 19905, and then A minus B is equal to 1905. Okay, so if you have A plus B plus A minus B, which is basically this whole thing, and this is equal to 19905, okay, and then plus 1905. Okay, so in this case, we will then get 2A equal to 19905, 1905. This will be the 21810. Okay, so 1A will then be equal to 110,905. No, so this will be, okay, you know what? Alright, so what we can do is we can actually draw a model. So let's say the bigger number and we have the smaller number. So the bigger number over here is definitely bigger, right? And then we have the smaller number as well. So smaller number. So the difference over here would then be equal to 1,905. That would look something like this, right? 1905. Okay, so in this case over here. And we know that the sum or the total itself, it's 19905. So this will then be 19905. Okay, in this case over here, right? So then what can we do? Okay, since we know the difference is 1905, then in a way we can just have like 2 units, right? So what we see over here, right? So this will then be 1 unit, and then smaller number is just 1 unit. So that means 2 units would then be equal to 19905, okay, minus 1905, which is basically 18,000. So 1 unit, or the smaller number, is equal to 18,000 divided by 2, which gives us 9,000. Okay, so the answer to this question is 9,000. So I see over here. All right. Okay, let's move on to the next question. Okay, question 10a, express 1/4 as a decimal. So 1/4 is basically the same as 1 divided by 4. Okay, so there's multiple ways you can do it. You can either, number 1, so you have 1/4. You can just multiply both of this numerator and denominator equal to, right? You can multiply both of them by 25. So if you have done this kind of question, this will be very straightforward. So this will be 25 out of 100 in this case over here. Okay, so that is like, to me the easiest for you to just have this kind of answer. So 25 out of 100. So 1/4 is basically 25 out of 100, which is basically equal to 25 divided by 100, which is 0.25. 0.25. Okay, otherwise you can also do division as well. So this is one way is to just have have denominator be 10, 100 or 1000. Okay, then second, so this is the first, not one way, first way. Second way is to just divide. Okay, so in this case 1/4 is equal to 1 divided by 4, and this will be 0.25. Okay, so I'll show you how the workings will look like. Alright, so it will look something like this, where you have 1 divided by 4, right? So it's essentially 1.00. Then you can just do the normal division, and this will become 0.25. So yeah, that is it for question 10A. For question 10B, a class of students were divided into two groups, A and B. There were twice as many students in group A as group B. 1/4 of the students in group A were girls, 2/5 of the students in group B were girls. What fraction of the students were girls? Okay, we can draw a model, and it will look something like this, right? So we haven't finished drawing the model. So first thing is that from the question it says there were twice as many students in group A and group B. So in this case, group A is 2 units and group B is 1 unit. That's what you see over here. Then the next thing is 1/4 of the students in group A were girls. So in this case, 1/4 of 2 units, what will it look like? So essentially we can split this into 2 units. Split this into 2. So you have 1 and we have 2. Something like this. So 1/4, that means it will look something like this. 1/4 is girls, right? So girls may be pink. Right, and then 2/3 of the students in group B were girls. So that means we have to split this into 2/3. So we have 1, we have 2, and then we got one more, which is just an empty, just an empty thing over here, right? So you could see that this is how it looks like. So what fractions of the students in the class were girls? So in this case, we need to, in a way, find, I would say, the lowest common multiple, but it's not from 4 to 3. We need to find the lowest common multiple of this whole thing over here, okay, like this, right? Because we know that there were twice as many students in group A as group B. So after drawing the model, we need to find the lowest common multiple of 2 and 3, which is 6. So in this case, we can actually split them up, something like this. So we have split into 1, right? And then split like this, another 1. And then we can split into further half, right? Into 6. That's what you see over here. So now there are 6, I would say, parts to 1 unit over here. So in this case, if we were to further split A, okay, so we split 1 unit into 3. So 1, 2, 3, and 4. So in total, right, if we were to calculate how many parts are there in A, we have 3 times 4. This will then become 12 units, right, or 12 parts. 12 parts. And then for B over here, we have half of it, which is, in this case, 6 parts. Right, something like this, 6 parts, right? So in this case, A has 12 parts and B have 6 parts. So that means A total of A is equal to 12 parts, and then total of B is equal to 6 parts. So that means A girls is equal to, you can put 1/4 times 12. This will give us 3 parts, which is exactly what we see here, right? 3 parts in pink. Then what about B? Okay, so if you were to write the fraction, B girls is equal to 2 out of 3 times 12, which is equal to 4 parts. That's what you see over here, right? If you zoom it in, so we have 4 pink parts. So that means total girls is equal to 3 plus 4, which is equal to 7 parts. So fraction of girls, okay, in the class is equal to, so we have the total, so we also write total of students is actually 12 plus 6. This gives us 18 parts. So that means fraction of girls is 7 out of 18 parts, right? And that's the answer. Right, let's move on to the next question. Question 11. Mr. Kumar had the same number of donuts and cupcakes. After selling 84 donuts and 30 cupcakes, the number of cupcakes left was 4 times as many as the number of donuts left. How many donuts did Mr. Kumar have at first? Okay, we can draw a model over here. So I'm going to write here donuts and cupcakes. Right, so I see over here. So now we know that he had the same number of donuts and cupcakes. So we're just going to draw 2 of the same models for donuts and cupcakes. And then after selling 84 donuts and 30 cupcakes, the number of cupcakes left was 4 times as many donuts as left was 4 times as many as the number of donuts left. So how many donuts did Mr. Kumar have at first, right? So if you were to just, for example, selling 84 donuts, we will look something like this. Okay, and then this will then be 84, right? So I'm going to put here 84. Then for the cupcakes, it's only 30, similar to how we draw the sold, I would say, cupcakes. Okay, we'll look something like this. Oops, right? So this will then be 30. Then from here, I'll zoom it in. We know that the number of cupcakes left was 4 times as the number of donuts. So what that means is, this is 4 units, and for donuts, this means it's 1 unit. Okay, so can we, in a way, solve this? Yes, we can, right? So we can actually find the difference between these 2 sections over here. So let me just draw a line just to make it a little bit easier to see, right? So we can actually find this. So 4 units minus 1 unit, this will give us 3 units. And 3 units is equal to 84 minus 30. And this gives us 54, right? And then 1 unit will then be equal to 54 divided by 3. And this gives us 18, if you were to like calculate, right? So 54 divided by 3 is 18. Let me just double check. Okay, very good. All right, so now we know 1 unit is 18. How many donuts did Mr. Kumar have at first? So we can calculate donuts. So donuts is equal to 1 unit plus 84, which means it's just 18 plus 84. And this gives us 102 donuts. So to just double check, right, we want to check the cupcakes as well. So that means we can just have 4 units plus 30, which is equal to, let me just put this up. Okay, so 4 units plus 30 is equal to 4 times 18 plus 30. So 4 times 18 is 72. And then we plus 30, this gives us 102, which means this is correct as well, because we know that cupcakes and donuts at first are the same. So the answer to this question is 102. Let's move on to the next question. Question 12a, rectangle ABCD is made up of 5 triangles. AX is shorter than XB, and AX is equal to YC. So true or false or not possible to tell. Half of the rectangle ABCD is shaded. Okay, so we know that AX is shorter than XB and AX equal to YC. So what we can do is we can actually just assume certain things. So for example, let's say that this whole thing is 12 centimeter, right? Let's say. And to make this a little bit easier, this will just be 4 centimeters. Okay, so in a way, let's assume that rectangle length is 12 centimeters and breadth is 4 centimeters. Okay, because we can use these numbers for us to see whether, because we have different statements, to see whether if this statement and the other statements is either true, false, or not possible to tell. So we also know that AX over here. Let me just make this a different color. AX is the same as YC in this case. So what can we write down over here? So we can assume that this is maybe, what is 12? We can put this as 4 centimeters. We can put this as 4 let me make text instead. 4 centimeters in blue, right? And 4 centimeters in blue. Okay. So we can say, let's assume that AX and YC is 4 centimeters, which means that XB and DY is 8 centimeters. Okay. And this is true, right? AX is shorter than XB. Okay. Oops. So we say AX is shorter than XB. That's what we see over here, right? So I'm going to put this as, let me just expand this. Oops. This will be red. This will be 8 centimeters as well. So 8 centimeters. Okay. So since AX is equal to YC, that means the other side is also the same. That's what we see over here. Okay. So now we have a sense of these triangles. I mean the different lengths. The next thing is that we also can find the areas of these two triangles. That's what I see over here. So we have this, right? We have 8 centimeters for both the shaded triangles. Okay. And then we can figure out whether half of the rectangle ABCD is shaded. Okay. So first we want to get the area of the rectangle, which in this case is just 12 times 4, which is 48 centimeters square. Okay. Pretty straightforward. Now the next thing is area of one shaded triangle. All right, triangle. So in this case, what we can do is we can just have half. Wait, so let me just put the arrow. Why the arrow looks a bit weird? Okay, half times base times height. So area of one shaded, let's put it as dyx, the first one, right? On here, this one. Okay, this one over here. So what we can do is the base is 8 centimeters and the height is 4 centimeters. Okay, pretty straightforward. And this is 16 centimeter square. So I see over here. Now let's do the other one, area of another shaded triangle. All right, XBZ, right? So XBZ, same thing, half times base times height. Okay, so what's the base is 8 centimeters. Okay, and the height is also 4 centimeters, and this gives us 16. So total, I would say shaded over here is equal to 16 plus 16. Okay, so both are 16. Right, so 16 plus 16, this gives us 32. However, the area of the rectangle over here is 48 centimeters square, 12 times 4. So total area or total rectangle area is 48. So half of rectangle area is equal to 48 divided by 2, which gives us 24. So that means the total shaded is not equal to half of rectangle area. So that means this is a cross and this is false in it. Let's move on to the next statement. All right, 12b. So the next statement says the two shaded triangles have the same area. Okay, so if I were to maybe make the what do you call this? The two shaded triangles have the same area. So from the previous question itself, right? If we were to assume that the rectangle is 12 and the breadth is 4, and we calculated the area of shaded for one dyx, which is the left side, and for the right side xbz, both have the same area. So in this case, this is true, right? Okay, and then let's move on to the last statement. So the last statement says the total area of the triangle AXD and the triangle XBZ is half the area of the rectangle ABCD. All right. So in this case, we have the area of the rectangle that is 48 centimeters square. We have the area of the rectangle which is 48 centimeters square. We also know that the area of the shaded triangle is XBZ, which is 16 centimeters square. But we want to know the area of the triangle AXD, which is not the shaded one. So let me choose try. Okay, so area of this, and this is AXD. So AXD over here is the left side. So in this here is 4 centimeters and 4 centimeters like this. So what we can do is we can calculate it. So XD is half times base times height. So this will just be, since it's a right angle triangle, then this will be 8 centimeters square. Okay, so 4 times half is 8 centimeters square. So we know that the area of the rectangle is 48. So let's put, so area of triangle AXD, right, plus triangle XBZ, okay, is equal to, so AXD is 8. And then in this case, XBZ is 16. This is equal to 24 centimeter square. And then we want to get the half of the rectangle, area of rectangle. So let's copy this, paste it over here. So half of area rectangle is 48 divided by 2. And we know that this is equal to 24 centimeters square. So that means area of AXD plus XBZ is equal to half of area of rectangle. That's what I see over here, which means this is correct. So this is true as well. All right, let's move on to the next question. Jane has a question 13. Jane has a rectangular piece of paper with an area of 140 centimeter square, as shown in the figure 1. She folded it along the dotted line and obtained figure 2. The area of the shaded part is 3/7 of the area of figure 2. Find the area of figure 2. Alright, so we know that the total area of this figure 1 is 140 centimeter square. So I just put figure 1 area is equal to 140 centimeter square. Then we know figure 2 over here, the area shaded is 3/7 of the area of figure 2. Find the area of figure 2, right? Okay, so we know that the shaded part is 3/7 of figure 2. So what does this mean? So this means that the shaded area is 3 units. Okay, so let me just put this in red. So area of this is 3 units. And then at the same time, when you fold these two up, right, you see that we have 2 of the same triangles folded as well. That's what I see over here. Okay, 1 and then 2. Okay, so in this case, right, so figure 2 is basically the shaded part plus 2 same non-shaded triangle. Okay, since we know that, so 3/7, so shaded part is equal to 3/7 of figure 2, which means that shaded, so we can convert, let's convert 3/7 to units. So that means shaded part is equal to 3 units. And then figure 2, shaded part, figure 2 is equal to 7 units. Okay, so that means we have the 2 same non-shaded triangle, right, or in red. Okay, so in this case, let me put this in blue lah. So that means 2 what do you call it, triangles that are not shaded, 2 triangles is equal to 7 minus 3, which is equal to 4 units. So 1 triangle area is equal to 4 divided by 2, and this gives us 2 units. So that means this, right, so let me put this over here. This is 2 units. And then this is also 2 units. That's what we see over here. So now from this part, the next thing is we know that this whole thing is 140 centimeters square, right? 140 centimeter square. Pretty straightforward, but that means half of it. Okay, so we know that half of figure 1 is 70 centimeters square. And since this is folded shape, that means this part also is 70 centimeters square. So that means the half of figure 1 is actually also equal to shaded part plus 1 unshaded triangle, right? So let me just put here okay, 1 triangle, which means that it is equal to how many units? So how it is in units is equal to 2 plus 3, which is 5 units. And now we can figure this out. Okay, so half of figure 1, so that means 5 units is equal to 70 centimeter square. Oops, square, right? Okay, that means 1 unit is equal to 70 divided by 5, which is 14 centimeter square as well. So we want to find area figure 2. So what is figure 2? Figure 2 is 7 units. Okay, which means it's 7 times 14, and this gives us 78 centimeter square. Okay, there you go. This is a tough one, right? So 78 centimeter square. All right, and the answer is 98 centimeter square. Okay, there you go. So the answer is 98 centimeters square. Right, this is a tough one, but we made it. All right, let's move on to the next question. Question 14a. Wei Ling had a sum of money at first. She spent $80 on a dress and 1/4 of the remaining sum of her money on a bag. She then had 3/8 of her money left. What fraction of her money did she spend in total? Alright, so this is what we call a remainder concept. So you can go to easy1.sg/blog to find out more. So in this case over here, we actually just use the remainder branch. So it says here she spent $80 on a dress and 1/4 of the remaining. So we have the remaining, and then we have 1/4 of it on the bag, and then she was left 3/8 of the total. Right, that's what you see over here. Okay, so in this case, the question asks what fraction of her money did she spend in total? Okay, so for this question, pretty straightforward, because we know that what's left was equal to 3/8 of total. So how much she spent is basically 1 minus 3/8, and this is equal to 5/8 in total, right, of total. Okay, so the answer is actually 5/8. Pretty straightforward. So for part B, what fraction of her money did she spend on the dress? Okay, so in this case over here, we know that there is the remaining, and then what she's left over here. So that means we also know that this is 3/4. So left of remaining is basically 1 minus 1/4, which is 3/4 in this case. Right, so 3/4 is what is from the, in this case, from the remaining, and we also know that what's left is also 3/8 of the total as well. So that means the remaining multiplied by left, it's equal to left of total. Okay, so remaining times left of remaining, right, is equal to left of total. So we don't know what's remaining, but we know what's left of remaining, which is 3/4, and this is equal to, okay. So if we want to find remaining, then what we can do is we can have left of total divided by left of remaining. So we know what's the left of total, which in this case is 3/8. So that means for remaining, we know that this is left of total, which is 3/8 divided by 3 out of 4, which in this case 3 out of 8 times 4 out of 3, and this should be half. So since remaining is half, that means the dress is basically 1 minus half. This gives us half. So the answer is half. So lastly, part C, how much money did she have at first? So since we know that half is equal to half of total is equal to $80. So that means total, or 2 out of 2 of total is equal to 2 times 80, which is equal to $160. And the answer is $160. Alright, there you go. So that's the answer. Let's move on to the next question. Question 15a. Muthu drew a gray right angle triangle as shown below. Find the area of the triangle. Okay, so for the area of the triangle, pretty straightforward. We have half times base times height. So the base over here is 4 centimeters, right? And because it's perpendicular, and the height will be 3 centimeters. So it will be 6 centimeters square. Okay, so that's the area of the triangle. Let's move on to part B. Okay, so question 15, part B. Muthu drew a grey right angle triangle as shown below. He then continued drawing more identical grey and white right angle triangles in a row to form a figure with repeated pattern as shown below. The perimeter of the figure is 114 centimeters. Find the area of the figure. Okay, so in this case, let me zoom this in. Alright, so we have all of the triangles as what we see over here. So in this case, this whole pattern, right, we essentially, let's give a simple example. So for example, the slanted line over here, let's make this red. Okay, the slanted line is 5 centimeters. So that means this slanted line over here will be just also 5 centimeters. So I'm going to write here 5 centimeters. Okay, so I want to make it to just have a smaller version of this whole figure. So if we have 5 centimeters over here, then that means we also end on the other side as 5 centimeters. Because over here is also 5 centimeters, right? So if I were to drag this, it's 5 centimeters. But I want a smaller version because it's easier to understand how to calculate the number of triangles. So now the next thing is we want to know what is this, I call it, what is this length for each of these triangles, right? So let me use an arrow instead. Okay, so what is this length? Okay, so from the small little triangle, is it 4 or 3 centimeters? So it's actually, in this case, it's 4 centimeters. Okay, so because that's the base, 4 centimeters. Okay, so if I were to, make this, okay, also let me add a green line as well, the 3 centimeters. Okay, so copy it, group this. Okay, so with this, if I were to put the triangle as such, okay, you see that the height is not counted. If I were to flip the other way, you see the height is not counted. If I rotate it, you could see that the height is not counted. And if I flip it again, you can see that the height is not counted, and you continue from there again, right? So you flip it again, the height is not counted. So the only thing that's counted over here is the base, 4 centimeters. And then we have, in this case over here, we also have 4 centimeters. Okay, and then we also have another 4 centimeters. And then from here, we also have 4 centimeters. Okay, so with this small version of this, how many triangles are there? So in this example, I'm going to write here example. So example, we have a total of 6 triangles, right? So for example, we have 6 triangles in this case. So I'm just going to put a rectangle like this. So example, we have 6 triangles. So that means we will have a total perimeter of 6 triangles, which is equal to, then we have 5 and 5, so we have 5 times 2, plus we have 4 times 6, 4 times 6. Okay, so that means or 6 times 4, okay, correct, 4 times 6, right? And in this case, this will give us 10 plus 24, and this will give us 34. That's what I see over here. Okay, so for example, we have 6 triangles, right? So total parameter is this. So that means the equation for total parameter is basically 5 times 2 sides plus 4 centimeters. Okay, I'm going to put here centimeters so easier. Times number of triangles. Okay, so we want to find the number of triangles, right? Because we want to find the area. So that means for number 4 centimeters times number of triangles, it's equal to total perimeter. Okay, and then minus 10 centimeters. That's what I see over here. Then number of triangles. So to get the equation of number of triangles, we need to work backwards, right? So 4 times 8, and then that means number of triangles, and then be equal to total perimeter divided by 4. Divided by 4. Okay, so let's test if this equation is correct. So we know that the number of triangles is 6 triangles, so number of triangles of 34 centimeters perimeter. So in this case, will then be equal to total perimeter minus 10 centimeters divided by 4, like this, right? So we have total perimeter as 34, and then minus 10 divided by 4. This gives us 24 divided by 4, which is equal to 6 triangles. So that means this equation is correct. Equation is correct. So that means if you were to have 114, in this case over here, 114, then we will have the same equation, right? So 114 minus 10 divided by 4. So this gives 104 divided by 4. This gives us 26 triangles. So now we also know that the area of the triangle is so area of one triangle is equal to, in this case is half times base times height, and the base is 4 and the height is 3. This gives us 6 centimeter square. So now we want to get the area of 26 triangles, which is basically 26 times 6. This gives us 156 centimeter square. Okay, there you go. So the answer is 156. All right, let's move on to the next question. All right, so for part C, what fraction of the figure is made up of white triangles? So in this case, we want to go and focus on the, I would say, the smallest example. So if I were to just highlight this smallest example, it consists of how many? In this case, it's 6 triangles, right? 1, 2. So 1, 2, 3, 4, 5, and 6. So how many white triangles? We have 1 and 2. And how many shaded? 4, right? That's what I see over here. So if I were to expand this to maybe this part over here, right? So I manually draw, as what you see over here. Then that means this will then be equal to 10 triangles if you were to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now also, how many white triangles? 1, 2, 3, 4. And then how many shaded triangles? 1, 2, 3, 4, 5, and 6. Okay. Now let's expand it a little bit more so you can draw this as well. So I've drawn my example. That's what I see over here. So I think you might see maybe a pattern. So we have 14 triangles if you were to count this. Let me make this a little bit zoom out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we have 14 triangles. Then after that, how many white? 1, 2, 3, 4, and 5, and 6. And how many shaded? We have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we just want to concentrate a lot more on the white. So in this case, 6 triangles 2 wide, 10 triangles 4 wide, and 14 triangles 6 wide. So how do we get the wide? If you see the pattern, is actually just 6 divided by 2 minus 1. Okay, minus 1. So 6 divided by 2 minus 1 is 3 minus 1, which is equal to 2 wide in this case over here. Then we can do the same to the rest. So 10 triangles, how many wide? Instead of 6, this will be 10 divided by 2 minus 1, which is basically 4 minus 1 in this case. Sorry, not 4, 5 minus 1, and this will give us 4 wide. Okay, that's what we see over here, right? And then lastly, I think the same goes to 14 triangles. So that means if I were to just do the same thing again, which means this is 14 divided by 2, and this gives us 7 minus 1, and this gives us 6 wide. So remember the earlier number of triangles. How many triangles? It is 26, right? So we have 26. So that means 26 divided by 2 minus 1. So 26 divided by 2 is 20. What do you call this? 13. Okay, minus 1, we have 12 wides. So that means fraction of wide in figure, it's basically just 12 out of 26. If we simplify this will be 6 out of 13. Okay, there you go. So the answer is 6 out of 13. Let's move to the next question. Question 16a. Mrs. Tan bought 3 times as many plates as cups from a shop. She spent $340 in total, and the amount she spent on the plates was $240 more than the amount she spent on the cups. The cost of each plate was $2 more than the cost of each cup. How much did Mrs. Tan spend on all the cups? Okay, for this we can draw a model, a pretty straightforward model. So we have here plates and cups. Okay, so this is what we call value times, I forgot what it called, but yeah. So she spent $340 in total, and the amount she spent on the plates was $200 more on the cups. So the plates over here is $200 more. So I'm just gonna put here $200 more. $200. Okay. And then the total over here is 340. Okay, so I think from here we can know how much is 1 unit, right? So I'm gonna put here 1 unit. Okay, 1 unit and 1 unit. So that means 1 unit or 2 units is equal to 340 minus 200, which is equal to $140. Okay, and then 1 unit is equal to 140 divided by 2, which is $70. Okay, so how much did Mrs. Tan spend on the cups? It's just $70. Alright, let's move on to the next part. So the next part is part B. So for part B, how many cups did she buy? 6. Okay. For question 16b, how many cups did she buy? So in this case, we can draw some models. First clue is Mrs. Tan bought 3 times as many plates as cups from a shop. So in this case, we can just draw some models. So we have 1, okay, 2, and then 3. So this is 3 plates. So I'm going to write here plates. Right, so the plates, and the plates. So 3 times as much as the cups. So I see over here, right, the cups. That's what, like this, okay, cups. All right, then another clue is that the cost of each plate was $2 more than each of the cup. So let's say we have 1 cup and 3 plates. Pretty straightforward. So that means for this plates over here, we have $2 more, right, than each of the cups. So $2 more, $2 more, wait, word, then $2 more, $2 more. Okay, so let's say, right, we have 1 cup and 3 plates. Does this make sense? Yes, right? So, and then let's say 1 cup is $5. Okay, so, or should we put 10? 10 also can, $10. Let's put $10. So instead of $2, then this will be $10. So since we know that cups is $10, that means the plates is also $10. right? Okay, so that means the total for the plates. Okay, so that means the total for the plates, okay, or 3 plates in this case, okay, it's equal to, right, 10 times 3 plus 2 times 3. This gives us $36. Okay, so why I'm doing this, because we also know that the total amount that she spent for the plates as well from the previous question. So I'm gonna write it on top. So total amount spent on plates is equal to 270, right? And then total amount spent on what do you call this? Cups is equal to $70, like this. Okay, so we already know this too. So I just want to just share how this looks like. Okay, so and this is $36. And then we have cups, which is just plainly $10. Okay, as what you see over here. Okay, so let me just make this into green. Okay, and then this also green, because yeah, same. Okay, so now pretty straightforward. We have 1 cup, 3 plates. What if, okay, we have a bunch of, this is one group, right? So I'm gonna put this in purple. So this is one group. What if we have another group? Okay, another group of this, okay, and this group, okay, we're going to put it over here. Okay, so I'm gonna stretch this out. Okay, so this group over here, just put it like this. So what's the total now? Okay, so the total now for this is 72. Okay, so 72, and then the total cups is $10. I mean 20. That's what I see over here. Right, pretty straightforward. Okay, so I'm gonna extend this example. So let's say we have 1 cup. Now we have 2 cups. Okay, 2 cups and 6 plates. Okay, still the same thing, right? 3 times as many, right? So 1 cup, total for 3 plates is, instead of 10 times 3, this will be 10 times 6, 2 times 6, and this will give us $72. Okay, from here, from 36 to 72, we can get the number of, what is this? 10 times 3 plus 2 times 3, right? So 72 over here as well. Right. So the thing is that the cups, since it's $20, okay, right? Total cups is $20. And then we also have 2 times 6 in terms of the number of plates, right? The difference. So in this case, if we were to combine them, essentially, it will look something like this, right? So let me ungroup it and ungroup this. So the plates over here, technically, right? Let me just remove the plates and the cups. We have a total of $20. That's what I see over here. And then we have this $2 like this, right? We have $10 and $2, right? We arrange it like this. $22, $2, and then we have $72. Right? So from what we see over here, and since we know the number of plates, then we can just divide it by 3 to get the number of cups, right? So for this, what we can do is, since we know that, let me just remove this and the $10 example, all right? So number of plates over here, we know the total is 270, right? So let me just remove this. So this will then be 270, and the total amount spent on the cups is $70. So I see over here, right? $70. Okay. So essentially, in a sense, it looks something like this, and this is how we get the number of plates, and this is also the plates difference. I'm gonna put here as plates difference. Okay. So in this case, we can actually get the plates difference first. So plates total plates difference is equal to 270. Okay, minus, since we have 7 cups over here, 3 cups, so 3 times 70, and this will give us $60. So we can get the number of plates, which is basically 60 divided by 2, which is 30. And since plates is 3 times as much as cups, which means plates is equal to 3 times as cups. That means cups is equal to plates divided by 3. So since we know the plates total is 30, right? So that means cups is equal to 30 divided by 3 is equal to 10. Therefore, the number of cups is 10. Alright. That's it. If you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below and comment down what other things you want me to show you next. See you in the next one. Bye bye.